This video is for Geometry Chapter 11, Assignment number 7, on finding the volume of prisms and cylinders. So a prism is a solid that has two faces that are parallel and congruent, and the lateral faces of the prism are rectangles or parallelograms, most often rectangles. So here's some examples of some prisms. This one is a triangular prism because the two bases that are opposite and parallel are triangles, and then these lateral faces that I have shaded red are rectangles. This is also a prism. Notice that there are four rectangles, and the shape that is not a rectangle is a trapezoid. So it's a trapezoidal prism, and the two trapezoids are congruent and parallel to each other, meaning that they are both that they'll never intersect. One's not slanted compared to the other. This is called a rectangular prism, and all the faces are rectangles, so that's a little confusing, but you can think of any two of them as the base, and then the remaining faces are rectangles. It doesn't matter if the blue ones are your base, the red ones could be the base, and then the remaining faces are rectangles, or the green ones could be the base, and it makes no difference. But on a triangular prism or a trapezoidal prism, then you need to make sure that the shape that is not a rectangle is what the shape that you consider to be the base. So triangular prism, trapezoidal prism, the base are the trapezoids, and the rectangular faces are called the lateral faces. So if I want to find the volume of one of these, I just find the area of the base, so in this case the area of the triangle, with 1/2 the base times the height of the little triangle, and then multiply it by the height of the prism. Now it can be a little confusing that we've got two heights. The triangle, if you just think of it as two-dimensional, has a base and a height, and the prism itself has a height. So when I'm talking about the height of the prism, I like to use a capital H, and if I were doing a small formula to find, say, the area of the triangle, I would use a lowercase, 1/2 the base times the height. So the volume of a prism is always the area of the base times the height. So you could fill in this B is really the area of the base, and you could shade this, that's the area of the base, or it could be the top, it doesn't matter, you find the area of one of those. Here, even if the figure is kind of slanty, like you would take this, and if it was not rigid, I could kind of slide these away from each other. That doesn't change the volume, so it'd still be the area of the base times the height. And for a cylinder, even though it's not technically a prism because the top and the bottom are not polygons, but they are circles, and it follows the same pattern of the volume is the area of the base times the height of the prism. So we're going to do a few examples here. I'd like to look back at this one though. If I were finding the volume of this and I found, say, the area of the base, so if I thought of the blue as the base, it would be 4 times 7, and that would give me how many squares are in this little blue face here, and then I would multiply it by the height of the prism, because there would be 28 squares in the bottom row, and then times 6 stacked 6 high, so the answer would just be 7 times 4 times 6. 7 times 4 to get you the area of the base, and then 6 times to have the little blocks be stacked up inside. So remember when you're finding volume that you are just finding how many little cubes fit inside. So if I were using this one, and I found the volume of this rectangular prism, I would be finding how many of these little cubic centimeters fit inside of that. So volume is always measured in cubic because you're saying how much it can hold. And this is a cubic centimeter. This is a cubic inch. And so depending on how we're measuring things, that's how they fit inside. So this is quite a large tank because it's 15 meters by 4.5 meters by 9 meters. And obviously it's just a drawing and is nowhere near to scale. But if I were going to find the volume of it, I would write down that the volume is equal to the area of the base times the height. And in this case, I'm going to think of this as the base. Might be a good idea to always shade the base so that you remember what shape you're considering the base. And then I should have shaded that in green to match my color scheme here. And then this is the capital B height. So the volume, the area of the base would be the base times height of this little rectangle times the height of the prism. So we get 15 multiplied by 4.5 multiplied by 9, and the final answer is 607.5, and it should have meters cubed. All right, on the next one, we're going to find the volume of a triangular prism, and I tried to make that one match this one to scale here. So there's the 3, the 4, and the 8, and we are trying to figure out how many little tiny cubes would fit inside of this. And so our formula we'll start off with is that volume is equal to the area of the base times the height. And the base in this case is the triangle. Doesn't have to be sitting on the base like this. Sometimes they could be like, if this were sitting in this direction with the triangle kind of facing forward, the base is still the triangle even though the object is sitting on a rectangular face. The base is the shape in a prism that is not the rectangle, if there is a shape that is not a rectangle. All right, so the area of the base formula is for a triangle. So that's 1/2 little b little h, meaning the base and the height of the triangle, and then times the height of the prism, capital H. So that's the capital H, and these are the base and height of the triangle. And since it's a right triangle, I can use the 3 as the base and the 4 as the height. And so that's 12, half of that is 6, times the 8. And so the volume is 48 meters cubed. Notice that the area of the triangle, the green part, is 6, and then I just multiply that by 8 to get the volume of the solid. All right, so the cylinder isn't any different than the others. It's just that it is a little bit skewed, but that doesn't make a difference in the formula for the volume. The volume will still be the area of the base times the height of the cylinder, the distance between the bases. So this is the height of the cylinder, and the area of the base, since the base is a circle, is pi r squared, and the radius is 4. So it'll become pi times 4 squared times 7. So it will be pi times 16 times 7. And you could have skipped that step and gone straight to 16 times 7 is 112 pi centimeters cubed. And you could give the decimal approximation of that but I don't think it's necessary. I'm hopeful at this point that you all know how to type that into a calculator and get the decimal approximation, and I don't think we need to practice that right now. All right, so for the trapezoidal prism here, I tried to make this model match this figure, and I want to make sure that you understand that even though the trapezoid is sitting on this rectangular face, that is not the base. The base of the trapezoidal prism is the trapezoid, the one that is not the rectangle. So if you've got it sitting this way, you can see that this is the base. So when I go to find the volume, and I say the area of the base times the height of the prism, this one can be very confusing for students. There's two different heights in the problem. There's the distance between the bases, and there's the height of the trapezoid. So the capital H is this length, how far apart the bases are, and in this picture, how far apart the bases are. Here's the base, if I color that green. The two bases are 10 centimeters apart. So this is the capital H. And this 8 is the lowercase h if I was just finding the area of a trapezoid. So we should name this one a trapezoidal prism. And remember that the formula for the area of the trapezoid is 1/2 base 1 plus base 2 times the height of the trapezoid. And then to get the volume, I have to multiply by the height of the prism. So now I need to pick these values out here. So this 7 can transfer across. Those are the bases of the trapezoid, 7 and 12, and the height of the trapezoid is 8. So this will be 1/2 7 plus 12 times 8 for the area of the base, and then multiply that by the height of the trapezoid, which is 10. And 1/2 of 8 is 4, 7 plus 12 is 19, and this green part ends up coming out to be 76, then times the 10. So the area of the trapezoid is 76 times the height of the prism is 10, 760 centimeters cubed. So that is the volume of the trapezoid. Now I forgot on each of these to go through and clearly state their name, so state the name of each. So this one is a rectangular prism. This one, because the base is a triangle, is a triangular prism. And you might be tempted to call this one a circular prism, but it's not a prism by definition, and it is a cylinder. All right, so the remaining problems, so extra 8 there, are a little bit different. This one involves finding the volume of two solids and removing one from the middle. And these ones you're finding a missing variable. So the shape is a cylinder, and we're supposed to write and solve an equation to find the volume, to find the missing dimension, which is r, and we know that the volume is 486 pi. So you can start with the fact that the volume is the area of the base times the height, and the volume is then pi r squared. I think I'll just go with one color here. Pi r squared h. I know that the volume is 486 pi. I don't know the radius, but I do know the height of the cylinder is 6. And now I just want to solve this for r. So I can divide both sides by 6 pi. that will leave me with just r squared. And the pi's over here can cancel out. And 486 divided by 6, you're welcome to use a calculator, but that is 81. And so if the radius squared is 81, then the radius must be 9. Technically plus or minus 9 for the solution to this equation, but since we're talking about the radius of a cylinder, it can't be negative. All right, so number 6 is similar. You will find the volume is equal to the area of the base times the height. And the area of the base is just 12 times 15, and the volume is 2,700. So substitute the 2,700 in here. The area of the base is 12 times 15, and then leave the capital H as what you're solving for. And in the end, you should get that H is equal to 15. So pause it and try to fill in the steps there and see if you can get that. We are going to do this problem. I'm about out of time, so let's just set it up. The volume is equal to the larger rectangular prism, the outer one, subtract the smaller rectangular prism. And for each of them, it will just be the area of the base times the height, and then the area of the base times the height. So if you're finding the volume of a rectangular prism, it's good to know that all you have to do is multiply the 3 values that are given for it. So pretend there isn't the little tube cut out of this, and if I'm finding the volume of this box or a rectangular prism, I just multiply all 3 of these. 9 times 8 gives me the area of the base, and 5 is the height. If you thought of this face as the base, you would do 8 times 5 to get the area of the base, and the 9 would be the height. So I think it was safe to jump straight to 9 times 8 times 5 for the area of the outer one, and the inner one is 5 by 5 by 5. So minus 5 times 5 times 5, and work that out, and you should get 235 feet cubed. And this should have been 9 feet, and this should have been 15 yards. Okay, good luck. I hope that helps. And the homework is the second side of this handout to work on those. And notice that the answers to it are jumbled down here. These are jumbled answers. Thanks for watching.